Google Classroom, and that's where you'll get all your information.
Did you record your voice too, or just?
Just recording my voice and what I write. Yeah. Nah, not really. They can't really pick up the crowd very well. You got to kind of be right up tight to it. Yeah. Exponent laws. We've done 3 already. Okay, so let's review them. The first one we did was for multiplication. The multiplication exponent rule was if you have 2 bases that are the same and you're multiplying those bases together. Okay, so if I look at a question like that is 2 bases that are the same, the base is the bottom, and you're multiplying those bases, what was our rule that we could do to make that into 1 exponent or 1 power? You add the exponents. Right, so multiplying the base, we added the exponents, that became x to the power of 7. That was the very first rule that we learned. The second rule that we learned was our division rule. If we had 2 bases that were the same, and you were dividing those bases, we had a rule of what we could do those exponents. So for instance, if we had x to the power of 6 divided by x to the power of 2. That is 2 bases that are the same. They're both base x. We're dividing those bases. What could we do with those exponents? You could subtract them. This would become 6 minus 2, which is x to the power of 4. Those were the 2 main ones. We see those things like all the time. The third one that we learned, which was on Tuesday last week, I called it like power of a power. It's what happens when you have more than 1 exponent. So for instance, you have a base of x squared and then another exponent on top of that. We call that a power of a power, an exponent with an exponent. What do we do in those situations? Yeah. We multiply, yeah. So if we want to make that into 1 power, it becomes x to the power of 2 times 3, which is x to the power of 6. Those were the 3 rules we learned. Multiplication, division, and power of a power when you have multiple exponents. Cool. Let's see some practice questions with those 3 laws. So if we go to question 1, simplify means to write as a single power whenever possible. So if we look at this, this is a to the power of 4 times a to the power of 2. That should turn into the a to the power of 4 plus 2 to get a to the power of 6. Right? Add the exponents because we were multiplying the base. If you look at b, there's an invisible number there. The second power is b to the power of 1. Right? So remember, there's an invisible 1 there. If we're multiplying, this becomes b to the power of 7 plus 1, which is b to the power of 8. Right? Add the exponents. If we look at C, C is a little more complicated. We don't have any symbols in between these letters, which is one thing. And we've got brackets. So that looks scary too. That's not. What does it mean if you have nothing separating the letters? Yeah, it means multiply, right? So this is m times n squared. If you have brackets, anything against the brackets also means multiply, right? So this is just one big multiplication question. When you multiply with lots of letters like that, you can only combine bases that are the same base. So for instance, this m to the power of 1 can only combine with this m to the power of 4, become m to the power of 1 plus 4. The n's, n to the power of 2, n to the power of 6, can combine to become n to the power of 2 plus 6. Right? Like bases can go together. So the m's can combine and the n's can combine. And because it was all multiplication, I can order it out like that. To simplify this thing, I'd have m to the power of 5, n to the power of 8. Remember that one? A little trick here? Cool. If we look at D. D is a division question. Division means we're going to subtract the exponents. So this would become b to the power of 8 minus 8. 8 minus 8 is 0. What I get a lot as an answer is this, which is wrong. Why is that wrong? Excuse me, Nick, yeah?
Because if there's no seven or if there's no number, it's just automatically assumed as one.
Right. So that is an invisible number. That is an invisible 1. And 8 minus 8 doesn't equal 1. It equals 0. So this should be b to the power of 0. Now, we've talked about that too. We actually don't write things to the power of 0. The reason we don't write them is because they actually don't exist, right? That's what's going on here. So what this is saying is that there's no b's left. If there's no b's left, then I don't even need to put a b here. So the b is going to be completely gone, and we are going to put a placeholder number. What would that number be? 1. So anytime you have something to the power of 0, it just equals 1. Right? That's our placeholder value. Cool. You guys are doing pretty solid. If you look at E, that is also a division question. So you have n to the power of 10 divided by n to the power of 7. Because it's division, you're going to subtract those exponents. 10 minus 7 is n to the power of 3. There was another way that I did those questions instead of doing the subtraction rule. So the other way I like to do it was I would look at this and I would understand what's going on. This means that there's 10 n's. This means that there's 7 n's. If they started canceling each other out, like a game of war, right? The top would have more n's. And it would have more n's by 3, which is why it becomes n to the power of 3. The bottom would be completely gone because there's no n's left down there. Same answer, different strategy, right? Cool. Up here, we've got division again, but now we've got multiple letters. Bases can only go with like bases when you're doing exponent rules. That means your A's can go together and your B's can go together. If we focus on the A's, a to the power of 10 divided by a to the power of 2 would become a to the power of 8. Because 10 minus 2 is 8. The b's, b to the power of 6 divided by b to the power of 3 would become b to the power of 3. 6 minus 3 is 3. Wicked. Power of power rules. So this is when we start to get brackets and we got the exponent outside of the brackets. Our rule was if you have an exponent outside of the bracket that you bring it in to the brackets. So this would become 15 to the power of 3 divided by x to the power of 3. Right? You bring it into the other exponents. The one people usually forget to do is they don't bring the exponent to the 15. Right? It has to go to everything. If we look at h, we're going to do that same rule. So that exponent has to come into the x. It has to come into the 2, which is the one people forget. And it has to come into the y. So this becomes 2 to the power of 2, x to the power of 2, divided by y to the power of 2. Sometimes, especially with smaller numbers, we actually calculate them. So this 2 to the power of 2 is equal to 4. So that's 4x squared over y squared. Yeah.
You can take either one, right?
Yeah, I'd accept both answers. Yeah. I. Last one and trickiest one. So this 4 is going to come into the brackets to be the exponent on everything else. So it's going to come to this 1 to become 1 to the power of 4. Then it's also going to go to the x squared and to the x to the power of 3. When I'm bringing the exponent in, that's like having a power of a power. So that's multiple exponents now, right? This is x to the power of 2 to the power of 4. So what do I do when I have multiple exponents like that?
Next 2 4 times.
Yeah, you're going to multiply them. So you're going to do 4 2 times, which would be x to the power of 8. Right? Exponent of an exponent you multiply together. That means y would become y to the power of 12. Because 3 times 4 would be 12. Cool. Again, we would calculate that. 1 to the power of 4 is just 1. The denominator, x to the power of 8, y to the power of 12. Cool. That should have all been reviewed. Probably some parts of it were like, whoa, that's hard. But at the end of the day, most of it should have been reviewed. Cool. Our new exponent rule. Our new exponent rule is going to be negative exponents. We're going to talk about how you even get negative exponents and then how to deal with negative exponents. Okay, so let's look at this first. We're going to look at this little example, x squared divided by x to the 5. We're going to use the actual division rule, which is subtraction. Okay, if we were to use subtraction for this, you would get x to the power of 2 minus 5, which is x to the power of negative 3. Okay. Negative exponents. Hopefully you haven't seen negative exponents a lot. You might have last year a little bit, just kind of depending on what you were doing. But at the end of the day, we don't use them a lot. Going forward, so in math 10, 11, and 12, you are going to start to see negative exponents. And negative exponents aren't allowed. Right? It's like a written rule in math that you just don't write things as negative exponents. You have to write them as positive exponents. Yeah.
To its lowest sum.
Yeah, to like the lowest value you can. So like when we're looking at this, 2 minus 5 gave me negative 3, which is the lowest value we're going to get. And then we want to make it positive somehow. To realize how we could make this positive, we're going to do this same example, but in a different way. So if we redid this question, and we used my method of thinking about what we have. So if we looked at this question, this means that you have 2 x's on the top, and it means you have 5 x's on the bottom. Agreed? That's what this means. This is x times x. This is x times x times x times x 5 times. Cool. I pretend to go to war, right? Like a game of war. For sure. So I've got 2 on the top. They're going to battle a 5 on the bottom. Who would win that battle? The bottom, right? Because there's more of them. There's 5. So the bottom would win. How many would it win by? It would win by 3. And the top value would be all gone, so we would put a placeholder of 1. Now, I just did that question the same way. Sorry, same question a different way, and I have 2 different answers. This one, I used the subtraction rule. I got x to the negative 3. This one, I used my way of doing it, and I got a positive value on the bottom. So what that means is that these 2 things must be the same. This and this are the same. This gives us our negative exponent rule. Our negative exponent rule means that if you have something with a negative value, you need to turn that thing into a fraction if it's not already, and you move that power to the other side of the fraction. That leaves you with 1 over, and then 1 times x to the power 3, which we just put x to the power 3. So you can move the power from the numerator to the denominator, and it will change the symbol for you. That is going to be our negative exponent rule. It's got some weird intricacies to it, some weird situations you're going to run into, but for the most part, all you're going to be doing is taking powers and moving it from the top to the bottom, or the bottom to the top. And when you move it, it changes the exponent to be positive. Negative became positive. All right. That exponent rule is written out right here on the next page. So it's already written for you. In this example, they've taken negative m. They've turned it into a fraction. They moved it into the bottom, and now you'll see that the m is positive. Negative, move to the bottom, now it's positive. This one, they go the other way around. Negative exponents on the bottom, move it to the top, make it a positive exponent. And there is an invisible divide by 1 there. Right? We just don't typically write divide by 1. Yeah. Yes, sir. It's kind of a weird rule because it doesn't really make a lot of sense. It's hard to make sense of it. Yep. Cool. Let's look at a couple questions so we can see how this gets challenging. We'll look at A. We want to simplify that. Simplify means write as 1 fraction if you can, or 1 exponent, 1 power, and make sure all the exponents are positive. That thing is negative. So to simplify it, we need to make it positive somehow. To do that, you have to move it to the other side of the fraction. There's not even a fraction there. So you need to turn it into a fraction before you can even do anything. This is a divide by 1. Anytime there's not a fraction, turn it into a fraction. Just by going divide by 1. And now I can move this power to the other side of that fraction. On the top, there's now nothing left because I moved that n. So you put a placeholder value of 1. On the bottom, I've now moved those n's. So I have n to the power of positive 2. It is no longer negative because I moved where it was. That would be your solution. Took my negative power, moved it to the bottom, that turns it positive. It's kind of a weird rule. Let's look at B. Okay, there's two tricky parts to B. First part is realizing that this is an invisible divide by 1. Right? Anytime you don't have a fraction, turn it into a fraction. Cool. Second hard part. The second hard part is figuring out what has an exponent that's negative and what doesn't have an exponent that's negative. So for instance, when I look at this, does the number 4 have a negative exponent? What's the exponent on it? There's an invisible 1 right there. That 4 is not attached to that negative 5. That negative 5 is only attached to the x. That means only this thing I circled in blue is the negative power. That negative power has to move. Any power that's positive does not move. So the 4 to the power of 1 will stay on top of your fraction. The x to the negative 5 will move to the other side of the fraction. Turning this into 4 to the power of 1 on top, divided by x to the power of 5 on the bottom. You only move negative powers. Positive powers stay where they are. It sounds easy. Sometimes it's hard to know what needs to move and what doesn't need to move. Let's try this one. I look at that. I recognize I have a negative power. My negative power is right there. This time, it's on the bottom of a fraction. So we need to move it to the top of the fraction. And by moving it to the other side of the fraction, it will turn it positive. So this becomes x to the power of 3 on top. Is there anything left in the bottom? Nope. So you could put divide by 1 if you want. And you could do that. Or you could just write x to the power of 3. Right? We don't typically write divide by 1. If you do, it's not wrong. We just don't typically write it like that. Find negative powers, move them to the other side. Perfect. Let's try D. Identify your negative power. My negative power is right there. The x squared is positive, so it shouldn't move. Only negative powers move. That thing needs to move to the top. When you move it to the top, the x squared is still there. Now the y to the power of 4 is beside it. And it turned positive because I moved it from the bottom to the top. In the denominator, the bottom of the fraction, there's nothing left. So if you want to write divide by 1, you're more than welcome to. If you want to just write it without the divide by 1, that's the same thing. The key is that the negative powers move, nothing else. Yeah, for sure. All right, E. We'll do E together, and then I'll give you a few chances to do some on your own. Okay, we're looking at E. The first thing I would do is I would deal with this power outside the brackets by moving it inside the brackets. So that this becomes x to the power of 2, 2 to the power of negative 5, x to the power of negative 5. So I brought it in. Then I recognize I have two x values. That's one power with an x as a base. That's another power with x as the base. If I'm multiplying, what can I do with their exponents? I can add them, right? So I can add those exponents because I'm multiplying bases here. So 2 plus negative 5 would be x to the power of negative 3. The 2 to the negative 5 has not changed. I'm going to give you a moment just to write that down, look at it. That's new to us. Does that make sense? I brought in the exponent. I combined my multiplication. Cool. And then I realized my answer has negative exponents. Negative exponents are not allowed. So I need to move those powers to the other side of the fraction. If you don't have a fraction, make it a fraction. In this case, my 2 to the negative 5 is negative power, so it needs to move. My x to the negative 3 is also a negative power. It needs to move. That means there's nothing left on the top. So I put a placeholder of 1 on the top. The denominator would be 2 to the power of 5, x to the power of 3. And that's my final answer. I now have all my letters combined, and I have positive exponents. Yeah, for sure. Okay, let's try F. Yes, sir. Yep. If you look at F, you have one negative power. That negative power is y to the negative 2. You need to move that negative power to the other side of the fraction. If there's nothing on the top anymore, you put a 1 on top. The denominator would be x cubed y squared. Why don't I add these? Nobody said it. Yeah. Different bases you can't add, right? So don't do too much. Yeah. Yeah, if they're two different values, two different bases, x and y can't combine, right? And that's what you want to look for sure. We got one last one. Oh no, two, sorry. So we look at that. These are the same base being multiplied together. So if it's the same base, I should add the exponents. Negative 4 plus negative 3 is negative 7. Then I need to deal with that negative power. If it's not a fraction, I turn it into a fraction. I move that negative power to the other side. This becomes 1 divided by x to the 7. Added the exponents, move the negative power. Now we've got one more left. This one. The first thing I would do is I would recognize I have an x on the top, x on the bottom. I can subtract those exponents. When you subtract them, this is like having 5 minus -3. If you put that in your calculator, 5 minus a negative is like adding. So it's x to the power of 8. That's a positive exponent. It's done. Cool. That's your negative exponent rules. Tomorrow we're going to do fraction exponent rules. So fractions would be a little bit harder probably. This page right here, I would like you to try right now. So see if you can simplify them. I'll go over them in about 5-10-ish minutes. And then we have a bunch of practice problems where the questions get a little bigger, a little harder. Okay, so you have lots of time to practice today. So this first one, I think you guys actually did a fantastic job. Most of you realize turn that into a fraction if it's not one. Take your negative exponent, move it to the bottom. If there's nothing on the top, you put a 1. So for the most part, I'd say we got that one right. That's good. Then we start to get into a little bit of trouble with when something has a positive exponent versus a negative exponent. So if you look at this question, we need to turn it into a fraction. But then we need to identify powers that have negative exponents and powers that don't have negative exponents. This power in blue is 2 to the power of 1. That is a positive power. It should not move. So if it's on the top right now, it needs to stay on the top. The x to the negative 2, that is a negative power. So the entire power needs to move to the other side. It's currently on top of the fraction. It needs to move to the bottom of the fraction and become x to the power of 2. That is your answer. What I'm seeing a lot of is people are just moving everything. And we're going like this. 2x to the negative 2. And we're writing it as 1 over 2 to the x to the 2. That is not correct. Because this 2 had a positive exponent. So it shouldn't move. Only negative powers move. If we look at C, what I saw a lot of was that people took this and they said, that's a negative exponent, move it to the top, and they also move the 3 to the bottom. That is not correct. The reason it's not correct is because this 3 has a positive exponent. Therefore, it should not move. It should still be on the top of my fraction when I've done my answer. So instead, what I have to do is recognize that's positive. It stays on top. This is a negative power. It moves to the top. And then if you want to write divide by 1, you're more than welcome. Or you could just box that up. Positive exponents have to stay as a power. Negative exponents move. You can't just move everything. If we look at D, the same problem happens with D. Only negative exponents move. That means this thing in blue, that is a negative power. It has to move. This thing in red, that is a positive power. It should stay where it is. So when I write my answer, the blue should go to the bottom to make it positive 6. The y should stay on the bottom to keep it positive 4. And if there's nothing left on the top, you put a 1. What I saw a lot of this. People just moved both things. That is incorrect. You can't just move everything. Technically, if you did that, this should be a negative 4 because you moved it, right? And moving it changes the symbol. Don't move positive powers. Keep them where they are. If we look up here at E, the first thing we had to do was bring that negative 2 into the brackets. Remember, it goes to the exponent. So this would become 2 to the negative 2, x to the negative 2, and the other x to the negative 3 is still there. Then I recognize I have 2 x's. Those things should combine by adding the exponents. Negative 2 and negative 3 will add to become negative 5. Cool. Now, move negative powers. So this 2 to the negative 2 is a negative power. This x to the negative 5 is a negative power. So they both need to go to the other side to become 1 divided by 2 to the 2, x to the 5. F. Only negative powers move. The y squared is a positive exponent. It should not move. So it'll still be on the top. The x to the negative 5 is a negative power. It needs to move to become x to the power of positive 5. If you put divided by 1, that's fine, right? G. First thing I would do is recognize they're both base x. So I want to add those exponents. Negative 7 plus 3 becomes negative 4. That's a negative power. It needs to move to the bottom to become 1 over x to the 4. I think what confuses people is examples like that. And they're like, well, you move the 1 from the bottom to the top. I never moved this 1. It's just a placeholder. If there's nothing on the top, I put a placeholder of 1. It's a different 1 value. Guys, if you don't want to be here, this 1 is just a placeholder value. It's not that I switched where it was. It's just that there's nothing left here. And that's why I put a 1. If you look at H, you want to do the subtraction rule. So this would be x to the power of 5 minus negative 3. 5 minus negative 3 would be 8. That's a positive exponent, so I don't need to move it. Cool. I've got practice for you guys to work on.